In the previous video, we designed the architecture of our end-to-end data pipeline. In this video, we are going fully hands-on. We will set up a real Postgres source database that behaves like a production OLTP system. This database will be foundation for everything that follows. So this Postgres database will be representing a live application database. Okay, in real companies the database is this OLTP database is under a constant load from users, so we need to treat it very carefully. Okay, so let's start by creating a database. Let's name it create database app db. Okay, let's run it. What does say? Create database. Okay, my bad, there's a typo here. And let's refresh it. So appdb, right? Now I will be selecting the database as appdb, right? Because I will be doing all of my operations now on appdb. Okay, so now let's create a user table. So I'm pasting the DDL here. So this table has user ID as a primary key, to timestamp column created at and updated at, right? So the notice the updated at column, right? This column is very critical for incremental ingestion. We will be using this column to create our incremental ingestion in the future videos, right? So let's run this one and we'll be able to see tables under this one, right? Let me refresh this one and we have user table, right? Let's also create a new table called orders. So now you might have been able to understand what exactly I'm trying to do. I'm trying to create three tables here: user, orders, and then payments, right? Let me run this one. This one also has updated column, right? So orders can be orders an order might be created, paid, cancelled, or refunded, right? That's why we have created columns as well as updated columns. So you can you can order something, right? You go on Amazon and you order something and then you think like, okay, I don't think this is worth it, so you can go and cancel it, right? Or sometimes the seller cancels your order for some reason. So that's why we have two columns here: created at and updated at. Now let's create a payments column here. So you might be thinking why there are no updated at columns, right? Because payments, so users and orders tables are mutable, right? You can update something, right? In users, suppose they want to change their email ID, you can go, they can change the email, right? So that's why we have updated columns. We can change few data of users. Similar things is with orders, right? You can go and update a status as cancelled or refunded, something. That's why we have updated at. But payments are generally append only, right? These are immutable. So suppose you made some payments, right? You went and you did some payment and it was succeeded. You cannot go and mark it again as unsuccessful, right? That's not supposed to happen. That's why it's not mutable. That's why we don't have any updated columns here. Now let's start with inserting some data, right? Let's start with inserting our data to our user table, right? And let me refresh this one. Don't worry about the codes. I would be sharing the codes with you as a GitHub repo link in future videos. Don't worry about that one, right? So you can see we have this scheme of this user table. We have the data as this one, right? We inserted this data this one, right? I think I didn't create the payments table. Let me create the payment table. Yep. Now let me refresh it. We have payments table too, right? So this insert simulates user sign up, right? Suppose user with email address this, right, signs up to one of our application. So this one is simulating user sign up, right? Now let's update some data. So look at it, right? I'm updating table user, setting status is inactive, and marking the updated add column as current timestamp. Why? Because updated columns generally holds the data when this particular record was updated, right? So that's why. Let right now if you see at right for user number 2, the updated add column is same, not same. It should be it's same as created, right? Because there was no changes at that time. It was done first time, right? Now let's go and run this one. Right now let's refresh the data. I don't know whether it happens from here or not. Okay, let me close this and reopen it. Okay, so you can see, right, the status changed. Now updated at is also changed, right? The time was before 20 to 4:15. Now it's this one, right? Now let's insert some data to our orders and payments table. So I'm inserting into orders using user ID this one, amount of this one, and a status is created, right? This was done. Then let's insert some data to this one. So right now I'm creating a base, right? Base for the data that needs to be ingested for base of the pipeline. So this data needs to be there, right? So now if you will see, let me refresh this one again, and you will be seeing we have this data, refresh, payments, we have this data, orders, we have this data, right? So we have base for our ingestion right now. We have realistic transactional behavior right now. Okay, so in the next video you will see how this data flows into snowflake incrementally. Okay, so this Postgres database now behaves like a real production source. It has inserts, updates, relationships, right? Relationship, you will ask what is the relationship here? So look at it, right? We have relationship here, references orders as order ID, then references, right? User ID, orders table references user ID. These are creating uh, relationships, right? And it also changes states, right? You can see we have some updates. We were also doing updates here, right? There's some update data too. This is exactly the kind of source system data engineers work with in real jobs. Okay, so in the next video we will connect this database to Miltano and perform an initial load followed by incremental ingestion. That's where the real data engineering begins. Okay, see you next video. Thank you. Bye bye.